Hello class, so this is going to be just a, well, as quick as I can, a little mini lecture on circular motion. So I'm first going to go over the theory. So circular motion is, say, if it's a car circling along a racetrack, or at least the curved portions of a racetrack. Or it could be you have something on a string and you're twirling it, your headphones around your finger. So let's say we have something on a string, and you were twirling it so that it goes in a perfect circle. And I know that's not a perfect circle. Let's be imaginative here. So it's going in a perfect circle. So the theory is, so which direction is accelerating? So let's say it's at a constant speed. Alright, you kind of keep the twirl about the same. Alright, what direction is that speed? Is it the same direction, different direction? So think about speed and the acceleration. Alright, and think about what direction it's in. Try to quickly make a guess for yourself which direction these are in and why. Pause the video. Alright, so as far as it is at constant speed, the direction of that speed, we call it, it's tangential, which maybe you've heard the word tangent before in math class. In this class, when we talk about tan, it's tangent, so that means that along this line, so at any point, so say, hey, you let go of the string when it's here, it's going to go along this line and fly in that direction. For example, if you have been spun something around your finger and you accidentally let go, it shoots off in one direction that was probably exactly tangent to where it flew off in. So, for example, tomorrow I'm going to ask you a question. If I let go of it at this point, which direction will it fly? It should be tangent to the circle that it's going in. So it won't curve after you let go. It's going to go exactly straight. Nor will, it's not going to fly off. It's kind of what it feels like because you feel all this force on your finger when you're spinning it, but it will not fly off in any one direction. It's going to be exactly tangent to the direction it's going. So this kind of goes with Newton's first law, where an object in motion stays in motion in, the same direction. That direction would be along this line. It's at this point when you let it go, it's moving in this direction, which it will stay going in that direction. Alright, and the next is, it is accelerating. Why is it accelerating? It's currently changing direction. So maybe the speed is constant, but since the direction is constantly changing, you have to accelerate. So if we think about how it has to accelerate to change directions, well, every time we accelerate, we're actually going just a little bit. We can connect these lines. When you connect it to the next line, it's always going inward. And actually, your acceleration is inward. This is directly opposite of what you feel. We'll talk more of it tomorrow, but it's the idea that your car, to turn around a corner, you have to turn your car to the left. You have to make it accelerate towards the inside. However, you will get thrown to the outside because you're going to keep you're going to be that tangent trying to fly off. Your car is then you're going to hit the side of the car, and the car is going to push you inwards to keep you accelerating. We will talk more about this, but definitely know acceleration is always inwards, and that the speed of it is constant, and that it will be, the direction of it is at a tangent to this of the motion. So that's theory. Now we're going to go into some equations. Alright, so we need to know the formulas to 3 things for this. That would be how to find the average speed, how to find the acceleration, and how to find the actual force on an object. So speed is always going to be the change in distance over the change in time. However, we measure it a little bit differently for a circular motion because it's going around in a circle. There's only so much distance you really want to measure. So really what you want to measure is the distance on a circle, also known as the circumference. If you remember back to geometry or maybe even algebra, the circumference is 2 pi r. So it's 2 pi times the radius. And then you would do it over time, but you don't want to, you could take time forever and it's not going to change the circumference of your circle. So we say this with a capital T. This is the time for one rotation. So once around your circle or once around the 2 pi r distance. So this is the circumference. Where r is equal to your radius of whatever circle you are circling. So average distance is hopefully relatively intuitive for you. It's just your circumference, the distance traveled, over how long it takes you to go around that one distance or one rotation. Acceleration is, remember, it's the change in speed or velocity over the change in time. So we already figured out that this is velocity or speed, so you can say 2 pi r over t again. However, this starts to become an issue because it's harder to measure acceleration because it's not going around. You can only measure it going around one, so this doesn't quite work. So instead, what you should say is that, well, so we're going to take the velocity over time, or you can also write, we're going to have to essentially square the velocity. So it's going to look something like this. 4 pi, because we squared the 2 squared is 4, pi squared is pi squared, and then this r, and then we're going to divide it again by that t, but we squared it, so this is one way for acceleration. The other one would also be, we can just say our velocity or our speed divided by how far it goes. So again, t is equal to the time for one rotation, or once around the circle, and r is equal to the radius. So these are two formulas to find your acceleration. Notice that radius is absolutely necessary for both of them. Alright, and then force is still F equals ma. That does not change. The only thing is that now your acceleration is a little more complicated. So you're basically going to plug one of these two equations. This is the first equation, this is the second equation. You're going to plug those equations into your A here. That's the only thing that's going to change for this one. Alright, so tomorrow we're going to talk more in depth about these, but basically have the idea of which way is the acceleration and why, which direction is the velocity when it is released and why, and then know your different formulas for circular motion.